Okay, so if you haven't seen my community post, I did get COVID and I still have it. I'm a lot better now, and I feel like I can talk about what I need to for episode 2. And I realized I made that video in a really bad timing. 500 views in 5 days is really good. I very much appreciate everything. I'm almost at 1.03 thousand just because of that video. I got like 5 or 6 subscribers from it, and it's really good. Now, here I am making episode 2 finally. So yeah, we're going to be talking about what an entity is, but first I'm going to show you how to start out with your file. So open your favorite IDE like VS Code or PyCharm. I'm using PyCharm because my VS Code broke on me, and what you're going to do first is make a new file inside of your folder. Make a Python file, and this is in PyCharm, so I can just make one right here, but in any other thing you would do the name of your file .py, so .py, and this is just what PyCharm does for you. So I'm going to name it main, and see main.py. Now, I am still sick, so bear with me. We're going to be talking about what an entity is, the models, the textures, the colors, position, rotation, scale, the update function, the input function, the mouse inputs, and other functions. Now, an entity is a thing in the world and is the god class in Ursina. It's like the game object in Unity or an actor in Unreal. It can have a position, rotation, scale. It can have a model, texture, and color. It can have an update function, input function, and scripts. And for an overview of all its attributes and functions, in the description I'll link the cheat sheet for the entity. Now, let's get started with your file. You can do from Ursina import star or shift 8 and whatnot. And you'll do app is equal to Ursina colons or parentheses. At the end, we'll do app.run and another parentheses. So now you'll go in the middle of these two, and this is where you will work at. So let's make an entity. You'll type in entity, capital E, parentheses, and you'll do model is equal to, let's just do 2 marks right now. Now, there are several included models like quad, plane, cube, and sphere, both 3D and 2D, but you could also use your own. To do that, simply give the namebase of your model, and it will globally search for that model and take the first one it finds. Supported files are OBJ, binary format BAM, blend, it gets auto-converted to an object, and Ursina mesh, which is a custom human readable format, identical to how you'd make a mesh in code. Now, we're just going to do a 2D one, and we're just going to put quad, right? And that's basically it. We can run our file, and there we go. Let me center everything. Jesus, bear with me, I'm still sick. Transform, center to screen. Okay, so now we have your player, basically, if you want to call it. It's just an entity right now. It's nothing, you can't do anything with it. Now, let's, okay, so what we can do is set a texture with it. Now, setting a texture is similar to setting a model. Just give it a name, and that's all. So if you have a .png file, you can do player.png after doing, oh, here, let me scroll in for you. I'm sorry. You can do texture is equal to blank, and you can do cube.png and whatnot. You can have a .texture, setting it to another texture, like we have another entity. Model is equal to quad. Let's say we have this, but we want to use its texture. Let's just call it texture.png. Let's just say, oh yeah, we need to set this. So let's just say this is example 1 is equal to entity. This will be example 2 is equal to entity. Now we can take this away. We can do example 1.texture. And now we're using this texture as example 2's texture. Now we can also do it as a video texture. So if I copy and paste this 3, we can also do texture.mp4. You can set a video texture, which is pretty cool. And you can also set a pillow image thing. So this is how you do it. Texture, and it will be, pill. Oh, sorry. We have to import pill. Pill.image.new mode is equal to RGBA. Size is equal to, we can just do 256 by 256. And that's all. And there we go. we can position is equal to 1 0 0. We can just copy and paste this. We can do 2 3 4. Let's run it. Hopefully this works. No. Oh, and that's because I don't have textures. So for now, let's just remove this. And let's say I had textures because I don't. Let's just run it. Oh yeah, this doesn't. Pill has no attribute image. Huh? Whatever. It's whatever. No, it doesn't. I can't really test anything. Anyways, here, this might work better. Yeah, this would show better. Anyways. Oh yeah. You can also use a sprite. So S is equal to sprite of texture name, whatever you want to name it. Then you can print s.aspect ratio and see how much it is, or see its ratio. It's pretty cool. Now let's go on to coloring. We can also do, let's say entity1 is equal to entity, model is equal to, let's say cube, make it 3D this time. And you see that color is equal to color dot, let's say red. Now Ursina has its own color module installed within it, so that's pretty cool. We can do, let's just name this E to make it better. Now if we run it, it is a cube that's red, and we can change it. We can do e.color is equal to color.color, and this will be an HSV color. So we can do 120.5.5. Oh, whoops. Then we can run it. There we go. Makes it green. Or we can set it to an RGB color. Color.RGB. We can do 0.8, 0.10. And then we have a black. It's pretty cool. And you can also tint the color. So let's do e.color is equal to e.color.tint 0.1. And this might not work very well. Yeah, no. It turned it to a light gray though, because we tinted it. It's pretty cool. Or we can even set it to a random color. E.color equal to color.random color. We run this, purplish, run it again, green. It's pretty cool. Pretty cool. Now let's say we want a color halfway in between two colors, right? We can lerp the color, lerp the color.red, color.green, and let's just say 0.5. Jesus. Now, this is in between red and green. Let's do blue. So it's in between both of these colors. That'd make it a little purple. Let's do more 0.9, so it's more more blue. Let's do 0.1, so it's more red. And it's pretty cool. Now we're going to keep our little entity here. And let's run it. Boom, we have our little white square. Now we can change its position, rotation, and scale. So we have our entity, we can do e.position. And then we have two options. We can do this kind of coordinate system of vector 3 or vec3 and vec2 for a 3D or a 2D scene. So let's do vec2 for now. It's going to say 0, 0. Let's do 4 and 3. It's going to be more to the right and up, I'm pretty sure. Oh no, it's going to be off screen. Let's do 1, 1. See, it's more up. You can see there's a little line there to show that it's 3D. And let's change it to 2, 2. There we go. Now you can definitely see it's 3D. Anyways, that's pretty cool. You can also set its XY position on different axes. So we can do e.x is equal to 1. And we can change its 1. So it would be right here, but now it's right there. We can also do -2. Now it's tagged this way. Now we can also do a vec3, and this is where you take in the x, y, and z. Now let's do 1, 1, 1. See what? Oh, vec3, sorry. Now we see right here, it is, oh, I see what happened. It shouldn't have affected any. Hold on, let me change this. Okay, whatever. We can set it on different axes, the x, y, and z coordinate. X being this way, and y being this way, up and down. And z being, I guess, forwards towards you and backwards towards the computer. I don't know how to explain it, but it's pretty cool. Now, to set the position relative to the scene, that is ignoring the position of any parents, set .world position. So we can do .e.world position is equal to vec3 of 0, 0, 0. And we can also do print e.position. No, not debug. It's gonna be slow. Whatever. See, it's slow now because I accidentally did that. Okay, let's run it. There we go. It didn't print anything. No, it did. It printed the VEC000 we put. I can change it. You can't see it. It's down here. And then VEC3100. So yeah, it's working. Okay, now we can change its rotation. So let's make another entity. Actually, no, let's do its rotation first. So e.rotation is equal to 0, 0, 0. So it's not being rotated at all. And let's change its X to 4. There we go. You can see it's starting to lift up a bit. Let's do 45. See how that looks. You can see it's starting to come out this way. And you know what? Let's change it to another 45. And there we go. See, it's now facing this way. So it turned up and looked this way. So it's looking that way. I don't know how to explain it. We can change its color to color.azure, whatever this wants me to do. Stop doing the testing, whatever. This did not help. But whatever. We can also change its Z coordinate to, let's say, 170. No, that didn't really help. But if you get how XYZ works, it's not that hard to work with. I just work with 2D, so anyways, now you can do e.rotation, y is equal to 90. And we can change its specific rotation of y to 90, which did not work. Let's do 45. It did work, it's just 90 is completely straight the other way. But now you can see that it has a little turn, if you can. Now, let's make another entity. Other entity is equal to entity. Let's do its position is equal to, let's say, 1, 2, right? And we can change it color to color.red. Now let's make our entity look at the other entity. e.look underscore at other entity, sorry, OE, enter, or look. So now it's looking this way, because that's where it's, this way, because that's where it is. We can also do 1, 1. Now it's looking more the way it's supposed to be. So let's do 0, 0. Oh, sorry, hold on. Model is equal to cube. So now it's looking, let's change it to 1, and boom, it's looking to its right. Changes to 2. Boom, it's looking towards that way, which is pretty cool. So yeah, now let's change the scale of the entity. We can do scale is equal to, we can have multiple things, but I'm just going to do 1. So then everything gets bigger. Well, 1 is the baseline. Let's change it to 2. Now look how big it is. Change it to 0.3. Look how small it gets. Boom, down there. It's pretty cool. You can also do this by e.scale is equal to 2 and whatnot. But you can also do scale x is equal to 4. Now look how long it is. And it's pretty cool. Now let's learn about the update function. We can do def update, or okay, so here's an easier way of doing it. Def my update. We do e.x plus equals 1 times time.dt, which is just a current time management, which is really good. It's built in, I'm pretty sure. And we can actually implement this another way. Let's take this out. We can do class player of entity. We're going to name our entity player. Def update of self. Oops. Self.x, which is the entity, is plus equals 1 times time.dt. There we go. And we can just summon this. Oh, sorry, wait. We can do player is equal to player. And now we're calling our player. Oh, whoops. What's going on? Oh, okay, whatever. So you can just make your player that way, but I will be sticking to this way. Is equal to entity and all that. We can do def update or e.x plus equals 1 time.dt, and there we go. It starts moving to the right because we add 1, or we could subtract by 1 on its x-axis. Now I'll show you what happens if we don't multiply by time.dt. Oh, did you catch it? If you blinked, you missed because it went super fast. Now we do time.dt because it's a time management class to make things easier on ourselves. And the update function happens happens every tick. You'll see this in a lot of examples since it's convenient for small scripts. Keep in mind this won't work if you import a module with an update function defined at a module level. But yeah, we can also do a custom update, so my underscore update, and it won't work now. But what we can do is, oops, e.update is equal to my underscore update. Run this. Wait, whoops. Keep messed up. We run this and now it's moving because we're making its own update. And to make this easier, we can do the conventional method. Instead of having to write out e.update, we can do class player entity. We can make an initialization of self super dot init model is equal to quad, and this is a good way to customize your own character better. Color is equal to color dot azure, and here we go. Now we can do def update of self dot x. We can do plus equals 1 times time.dt. So we can get rid of this old code. Now let's look at it. Oh yeah, let's get rid of that import. We only have 15 lines of code, right? Okay, 17 now. Player is equal to player. And now look at this. Boom. We have the same thing as we had before. And it's even working. And we have it all in one class. So it's very much better and easier to customize. It's pretty cool. Now we can also take in its input, and instead of def update, we can do def input self and then key. We can do if key is equal to space. All right, let's do W instead. Self dot position plus equals self dot forward and run. Oh, see, and now it goes forward. You know, let's stop the update. We can do key equals D. Let's just do self dot animate. Rotation y, self dot rotation y plus 90, duration 0.1. Let's also do this for the A key, except we do minus 90. And oops, and we should be good. Then we go forward. We can also turn ourselves, which is really fast, times time.dt. Let's do this. Okay, that broke it. Whatever. COVID brain, not working that well. But yeah, it's pretty cool. You can rotate and you can change the position, self.forward, or you can do self.x plus equals 1 times time.dt, self.y, self.z, any of that works. It's pretty cool. Now I'm going to keep this here. We can also do we can also have a mouse function where it's print mouse.hovered entity, right? So let's run this and it'll say none, but we need to put that in an update function. Def update. Then we can do this. There we go. And it's not working. Whoops. Man, I actually never was able to get this to work for some reason, but it's okay. You can also do a myEntity.hovered, so like player.hovered, and that's false right now for some reason, even though I am hovering over it. It's printing out false in the console. But what you can do is on click is equal to action. You know what action is? Def action print ow you hit me. Let's see if this will work. No. Quad is your on click equals action. Oh, well, I'm stupid. Hold on. Let's just do model is equal to quad. Color is equal to color dot blue, I guess. Scale is equal to 1. Let's do 1.5, right? Let's do on click is equal to action. What? Oh, put period there. Let's run this. And boom, it's printing out, ow, you hit me in the console. It's pretty cool. Now, there are also functions for handling mouse clicks on hover and unhover, but these only work if the entity has a collider and the function is callable, or these only work if the entity has a collider and the function / callable is assigned. So we have on click, on double click, on mouse enter, and on mouse exit, so like moving your mouse into and out. It's pretty cool. And one example would be having a button. We can do B is equal to button, scale is equal to 0.5, 0.25, text is equal to ZZZ. Imagine someone sleeping. And then B dot on mouse enter is equal to function set attribute B text hi friend, and on B dot on mouse exit is equal to function set attribute B text no, don't leave me. Oops. we can just do one of those little silly faces. And yeah, let's run this. Hi friend, no, don't leave me. Hi friend, no, don't leave me. It's pretty cool. And it's a button, so you can click it. And yeah, it's pretty cool. And some other magic functions. Sometimes you want side effects when you enable / disable an entity, like playing animation or something. You also have on enable and on disable, which is pretty cool. Now, sorry for the long recording. Bear with me, I am still sick, and thank you.